Hello friends, I'm Paul Campbell. Welcome to my channel. Today I'm asking the question, just what is IRE? Well, IRE is the initials of the Institute of Radio Engineers. Now obviously from that name it goes back a long way. It was actually established in 1912 and continued until 1963 when it and the American Institute of Electrical Engineers merged into a new organization, the Institute of Electrical and Electronics Engineers. Now the IRE journal, Proceedings of the IRE, which was published monthly, can be downloaded from the World Radio History website. The link is in the description. It's at worldradiohistory.com. No surprise there. There's a lot of stuff there apart from the IRE journal. It's an interesting website. Now, before I go on, can I ask you to subscribe? It takes but a moment and you'll ensure that you don't miss my next video. Now, there were two major television standards in the 1950s, NTSC, National Television Standards Committee in the US, and PAL, Phase Alternating Line, in Europe and most of Asia. NTSC video levels for luminance ran from 0 to 714 millivolts, while PAL went from 0 to 700 millivolts. But really the voltage levels could be anything because they're amplified up from the sensor of the camera. Now the standard IRE scale is described in the May 1950 edition on page 552. There's not much to it. It just sets 0 at the blanking level and 100 at reference white. Now the blanking level, which relates to analog television, may be taken to be 0 millivolts. Reference white is defined as a specified maximum limit for white peaks. Now there is also a reference black, which was defined by the IRE as a term, but it's not actually part of the scale. The scale is just 0 to 100, and everything in between is percentage. Now in PAL systems, reference black is at 0 millivolts, but for NTSC it's at 54 millivolts. Now that's basically it. This is a copy of the graph that accompanies the description. Now note, IRE units as such are not defined in the standard. The scale is absolutely relative. 100 is placed wherever reference white is in the system. So the units, if you want to call them that, will vary depending on what system you're in. Reference white is the maximum signal value, sometimes called clipping level, and it's not to be confused with 90% white, which is another important level like 18% grey. The scale did go above 100. It went to 120 according to the IRE documentation. This was to allow for the measurement of abnormally high peaks. Now this standard refers to composite analog video back in 1950, before digital video was even conceived. It also specifies, once again, that 0 on the scale is at the blanking level. Analog video is obsolete. Blanking level means pretty much nothing to us today. The Institute of Radio Engineers has not existed since 1963. So what's the relevance of the term IRE today? Why is it still used? And what does it mean in terms of digital video? Well, today we don't see voltage or millivolts. We see digital numbers representing, I suppose, could be representing voltage, but the voltage is representing luminance. So we can say we see digital numbers representing luminance. We have 8-bit, 10-bit, 12-bit, 14-bit, 16-bit, and all of these have different numerical ranges. 0 to 55 for 8-bit, 0 to 1023 for 10-bit, 0 to 4095 for 12-bit. Now these numbers have no particular meaning on their own. The only reason we use them is because they belong to the particular digital system that we're using. You know, it's like measuring the distance from Paris to Milan, for instance. We can measure it in kilometers, or we can measure it in miles. Two different numbers will come up, but it's the same distance. Now consider this. Your camera, let's say it's the C100, outputs image data in 8-bit digital format using numbers from 0 to 255. Now that's not quite true, but more on that later. Now the same goes for my Sony a7 III. It's an 8-bit camera as well. But a camera like the Sony a7S III is a 10-bit camera and outputs its image data using numbers from 0 to 1023. It can also output 16-bit data to an external recorder. And that, 16-bit, uses numbers from 0 to 65,535. We could use both of these cameras and perhaps a Blackmagic 12-bit camera as well to shoot the same scene and import the results into an editor. So which of these sets of numbers would we use? Well, we use the same idea as the IRE used for composite video, and that's to use a scale from 0 to 100 with everything in between being a percentage of the maximum value. But unlike the IRE scale, we place 0 at reference black, not at the blanking level, and 100 is still at reference white. Now, I really think we should stop using the term IRE because it's confusing. People look at it and say, oh, what's IRE? Is that something different from percentage? Is it something I should know about? Well, it doesn't mean anything really. It's just a percentage scale, and really that's what we should call it. Things could be simpler if we just forgot about something defined over 70 years ago for an obsolete technology. And really, you know, using a 0 to 100 scale, it's not that much of an innovation. Now let's do an experiment. The C100 can generate color bars. Now these are test patterns used for calibration. Any video delivered for broadcast TV, for instance, will need to have color bars at the start. I've generated the EBU color bar since it's the simpler one to look at. Now, EBU stands for European Broadcast Union or something like that. European anyway. Right, so let's go into the menu system, go to Camera Setup. Down near the bottom, we'll find color bars. We'll enable them. We'll set the type to EBU. And the screen looks something like this, with a set of bright color bars. Now on the left is white, on the right is black, and there are colors in between. You've probably seen bars like this at the start of videos. Let's turn on the waveform monitor, and we'll see, as we might expect, white is at 100, black is at 0. The C100, by the way, can record menus and the characters on its display, but it can't record the waveform, and it can't record zebras. So for that reason, I use another camera, and record the display on the back of the C100. This is not a very high resolution screen, so it looks pretty ordinary. Now to get a clearer picture, I've used an external monitor on the C100, and I've recorded that on another camera. Now you can see clearly on this one that white is at 100 and black is at 0. Okay, so far so good. Now let's look at the specification for EBU color bars. Here's a chart. You might be surprised to see that white is at 235 and black is at 16. But 8-bit numbers run from 0 to 255. Shouldn't white be at 255 and black at 0? Well, not so fast. Welcome to Rec 709. This is a standard for HD TV laid down in 1990. It specifies 16 for reference black and 235 for reference white in the 8-bit system. These numbers were simply multiplied by 4 to give 64 to 940 for the 10-bit system. Now it leads to two different systems of levels. If you're preparing video for broadcast TV, then you have to use the Rec 709 levels of 16 to 235 or the 10-bit equivalent. They're called video levels. They're also called legal levels. Otherwise, you can use the 0 to 255 levels. These are called full levels. Now, here's the thing. Just looking at our C100. The color bars run from 16 for black to 235 for white. If we transpose those numbers onto a percentage scale for 255, we get 6 for black and 92 for white. But our waveform shows, as we've seen before, 0 and 100. We reach the conclusion, therefore, that the C100 is using video levels. Does this matter? Well, in fact, most cameras use video levels. Video levels are pretty universal. And editing software magically or automatically detects the levels we're using and treats the footage appropriately. Let's do another experiment. I've recorded a few seconds of the color bars on the C100 for wide DR. That's CP, Custom Picture 8. Let's have a look at them in DaVinci Resolve. Now I've brought up the waveform in Resolve from the color page and detached it so it stays visible in the other pages. Here's the output. Now on the waveform, on the scope, you can see clearly that white is sitting up here at 100 and black is sitting down here at 0. Exactly what you expected because you've just seen the waveform already. Now, let's take a look at the clip attributes. And what we want to look at here is this setting for data levels. Currently, it's set on auto. Let's change it to video and see what happens. And absolutely nothing. Well, let's try changing it then to full and see what happens. Full and OK. Now we see a change. As we saw before, when we transposed the settings of 16 and 235 onto a percentage scale, they changed to something around 6 and 92. And you can see that here, that the black is at 6 roughly, and the white is at 92 roughly. So that just confirms, of course, what we already know, that the output from the C100 is in video levels. When we switch to full levels, this is exposed because our range is now from 0 to 255, and the 16 and 235 can be seen to be inside that range. Let's change the scale to 10-bit scale. And this 10-bit scale, of course, runs from 0 to 1023. And we can see that the black is now at 64. It's halfway to 128 down here. And the white is up here at 940. It's a bit harder to see that it's at 940, but that's where it is. How do we explain this? Well, as we've discovered, the C100 records in video levels. Resolve automatically detects that the file is video level and sets 0 and 100 appropriately. So if we have it set to auto, we get this. If we change it to video levels, we force Resolve to treat the file as video levels, and as you might expect, nothing happens because it's already been detected as video, so no change. But if we select full levels, Resolve then shows the full range from 0 to 255. And now 0 is no longer at 16, 100 is no longer at 235, And as a result, what we were treating as pure black is now a lighter black, and what we were treating as pure white is now not quite white. The image has lost contrast. Now, if we start playing around with levels and get it wrong, we can really mess up our video, especially if we're delivering a video to someone who's expecting video levels and we have changed ours to full levels. It's not going to look quite right. Now, for this reason, it's recommended to let the software take care of the level setting, forget that it exists. Of course, after seeing this video, you won't be able to forget it. Now, in DaVinci Resolve, you can choose your levels in 3 places: Project Settings, Clip Attributes, and on the Delivery page. In all 3 of these, the default is Auto and should stay there. For delivery, Resolve knows what levels to use for any particular output codec. Now, of course, if you're recording video for broadcast TV, you need to be aware of the difference between full and video levels and ensure that your output is legal. Let's take a look at this clip, though, from the Blackmagic 6K Pro. This was shot in Blackmagic RAW. Now, strangely, the Blackmagic camera doesn't have the capability to generate color bars, even though it's a serious cinema camera. So I've just used a normal scene. Now, be aware that color bars are electronically generated. You can't just shoot an image of them. That would miss the whole point. They're electronically generated to an exact specification, as shown earlier in that chart. Okay, now I've grabbed a still from that clip, and we have it here, and we have the scope lined up underneath it. Now I'm going to take a look at the clip attributes, and this of course looks exactly the same as before. We have the 3 options for data levels: Auto, Video, and Full. Currently set to the default, which is Auto. Now let's change it to Video like we did before with the C100, and watch the scope and the image carefully when I click OK. And you should notice 2 things happening there. One, the scope changes, the blacks went down, the whites went up, and if you were watching the image, you'll see that the image has become a little bit more contrasty. Now this is the opposite to what happened with the C100. In its case, the image became less contrasty. All right, let's set the levels back to Auto. You go to the clip attributes, data levels, Auto, and just move that out of the way so we can see what's happening, and OK. And you should be able to see there quite clearly that the image became less contrasty as it went back to its original setting. Now we'll change it from Auto. We will change it now to Full and see what happens. Click OK. And we should see that nothing happens. Now this indicates that the Blackmagic camera is recording with full levels, not video levels, in contrast to the C100, and in contrast, I might say, to most cameras. Now, here's another interesting experiment. I'm using wide DR for this. I have a white background here with a light sweeping across it, creating a gradient. And I've set the exposure so that the brightest part of the background is well into overexposure. As you can see on the waveform, it's clipped at the top. I've recorded a few seconds. The waveform scale I've left as percentage. Now watch what happens if I change the levels to full. There was data above the 100. So although the camera is set white to 235, the data levels above 235 up to 254 were still recorded, and they're available to be recovered. Now this doesn't mean that you should change the level setting in order to get more highlights. That way, madness lies, I'm afraid. The data above 100, if it exists, can still be brought back by reducing the gain or the highlight settings in Resolve, like this. Now, here's another interesting thing. This is the mathematical equation for Canon log optoelectronic transfer function, otherwise known as the OETF. It's also called a gamma curve, but strictly speaking, it's not a gamma curve because a log curve is not a gamma curve. But the word gamma is very flexibly used these days, so I'll let that go. Here's a graph. Now, on the horizontal scale, the numbers are dynamic range. Underneath that, you can see some numbers for reflectivity, reflectance. Now, the dynamic range is calculated by setting 100 dynamic range, that's 100% dynamic range, at 90% white. Now, the numbers on the scales have been expressed as percentages for both scales. Now, actually, for the mathematical function, the numbers on the horizontal scale run from 0 to 8, and on the vertical scale from 0 to 1.2. But they've been expressed as percentages of their maximum values. Well, sorry, not the maximum values, but the horizontal scale is a percentage of the value at 90% white. Canon maps the luminance value onto the 8-bit and 10-bit scales according to what we see on this chart, as well as on the percentage scale. One thing though, for Canon log you can see that black, zero luminance, is at 7.3%, and it corresponds to 32 on 8-bit. Canon referred to this as setup. It's also known as pedestal if you look at your settings on your camera picture, your custom picture. You can see the data goes up to almost 109%. Now, although legal data only goes to 100%, it's also worth mentioning that the maximum value used on the 10-bit scale is 1016, even though the 10-bit scale goes up to 1023. The remaining numbers are reserved from system data. In 8-bit, only one number is reserved, that's 255. There aren't as many numbers there to spare. We might look at OETFs in another video. For a more modern take on video measurement, I'll refer to a document from the EBU, that's the European Broadcasting Union. The document is R103 from May 2020. R stands for recommendation. 2020 is a long time ago, but it's certainly more recent than 1950. The document is titled Video Signal Tolerance in Digital Television Systems. Now, among other things, it notes that readings in millivolts no longer give relevant information in digital signal infrastructures. It points out that in analog video, there was basically one range for luminance, 0 to 700 millivolts, or in NTSC, 0 to 714 millivolts, not a great deal of difference. But the signals could go beyond those limits on occasion. Now, in digital, this range would correspond to what's called nominal range. Nominal range is also known as video range, limited range, SMPTE range, narrow range, and preferred range. They're also called video levels, data levels, and full levels. Oh, and full range, of course. Complicated, isn't it? And confusing. Now, SMPTE, by the way, refers to the Society of Motion Picture and Television Engineers. It's the US equivalent of the EBU. The paper includes a really nice diagram showing the ranges defined for video levels today. I won't reproduce it from the document in case of copyright issues, but I've roughed up my own copy in Canva. Here it is. Now compare this with the chart for the IRE shown earlier. It's a different world, isn't it? I recommend that you look at this document if you're interested in video. Unusually, for a technical document, it's quite readable. The link is in the description. Well, that's it for today. I do hope you found something useful in this talk and that you subscribe. It doesn't take long, and it means a lot to me. It really does. Now, until next time, this is Paul Campbell signing off. Goodbye, and may your God, if you have one, go with you.